Hi guys, in this video we're solving for the tangential acceleration and the normal acceleration. Okay, so these are the formulas to find it. So to find the tangential acceleration, so this is the formula. So we take if we're given a vector function like this, so we take the derivative of it and then dot product with the second derivative of the vector function and then divide it by the magnitude of the vector function. And you can write this formula in the form of velocity and acceleration as well. So you know that the first derivative of position is velocity, right? So that's why it's v, and the second derivative is acceleration, so that's why it's a. So you can write this in the form of v dot a as well, and then the first derivative is velocity, so that's why the magnitude of v. So you can remember these whatever way works for you. Okay, and similarly you can do the same thing with the normal acceleration. So here you can find it in terms of kappa. If you're given the kappa, and if you don't know how to calculate kappa, I have made a video on that, so you can check that out. And so you can multiply the kappa times the velocity squared, so that will give you the normal component of acceleration. Or you can find it in terms of the position, so like taking the first derivative, cross producted with the second, and then divided by the first derivative, and similarly you can write it in terms of velocity and acceleration as well. Okay, now let's solve this problem. So here we're given a vector function, and we're asked to find the tangential and the normal component of acceleration at any time t. So here we're given at any time t. If we're given at the specific time, so we will plug that time into the t, and then we will solve for it, so we will get a value. But here we're finding for any time t, so we're just going to use this formula. Okay, so let's do this. So how are we going to do this? Okay, so we're looking for the tangential and the normal component of acceleration. So first of all, let's find for the tangential component. So to do that, our first step here, we see it's to find the derivative of the function, the vector function. So let's do this. So we are finding the derivative of the vector function. So here, remember this, that the sine of x, the derivative of sine x is cosine x, and the derivative of cosine x is negative sine x. So just remember this, it's a side note to help you at solving the derivative. So now you can solve it easily. So this is 5 cosine t, so 5 is a constant, so it stays there, and the derivative of cosine t is negative sine t, and then again the 5 is constant, and then what's the derivative of sine t? It's cosine t. Okay, so cosine t g hat. Now we're going to find the second derivative. So now let's calculate the second derivative. So here we have to do the second derivative of this function that we just calculated. Okay, so taking the derivative of this, so here negative 5 is a constant, stays there. What's the derivative of sine t? It's cosine t. Okay, I hat plus 5 is a constant, stays there. And what's the derivative of cosine t? It's negative sine t, so we have to put a negative here. Okay, just putting a negative here, and then sine t g hat. So this is the first derivative and the second derivative. So we have these two things that we needed. Now what's the next step? The next step is to take the dot product of this. Okay, so let's do the dot product. So r prime of t dot product with r prime of t. So you guys remember taking the dot product, sine t I hat plus 5 cosine t g hat, and then dot producted with the negative 5 cosine t I hat, negative 5 sine t g hat. Now dot product, we do I hat times I hat, and then g hat times g hat, and then we plus these two. So let's do this. So we do 5 sine t I hat multiplied by negative 5 cosine t I hat. So this becomes negative cancels out, right? So then this becomes 5 times 5, which is 25. And if you do sine x multiplied by cosine x, so which is sine t cosine t, simply. Okay, and then you do plus, and then 5 cosine t times 5 sine t. So what's 5 times negative 5? This is going to be negative 25, right? So let's write negative 25 for here. So wait a second. Okay, negative 25, and then cosine t times sine t, that's sine t cosine t. All right, and then so this is the dot product of it, and if you see clearly carefully, you can just cancel these out. This is 25 sine t cosine t, and then negative 25 sine t cosine t, so this simply gives 0. Okay, so the dot product gives 0. Okay, so next the dot product is 0, so if you divide it by the magnitude of the velocity, so that would give you 0 as well. So there is no point in calculating for the r prime of t magnitude. So we can simply write that the tangential component of acceleration is 0, because 0 divided by anything gives 0. Okay, so this is the answer for the A10. Now let's find an, the normal component of acceleration. So to find this, if we're given the kappa, we can find it, but here in this case we're not giving the kappa, so we're going to be using this equation. Okay, so the first step is to finding the r prime of t, the first derivative of the vector function which we already have, and the second derivative which we already calculated. Now we'll have to cross product them. So let's calculate the cross product of them. So this is r prime of t times r prime prime of t. So let's just write it here, I, j, k, and here the first thing is r prime, so that's why we're gonna write r prime of t in the first row. So then we write negative 5 sine t, and then 5 cosine t, and here there's no k hat, so that's why it's 0. And then in the second column, second row, we write r prime prime of t, the second derivative. Okay, so negative 5 cosine t I hat, negative 5, why did I write I hat? Okay, negative 5 sine t, and then again there's no k hat component, so it's 0. Now let's calculate the cross product of it. Okay, so how do we do that? So we'll have to cross out the ith column and the ith row, and then we do this times this, so we do cross multiplication. This times this gives 0, and then we do negative this times this, which gives 0 again, so this is just simply 0 I hat. Okay, so this is 0 I hat, and then remember this is plus minus plus, and for the negative, for the jth column you have to put a negative because it's negative, right? And then crossing out the jth column and the jth row, and then we do the cross multiplication again. So this times this gives 0, and then negative this times this gives 0 again. So this is a 0 j hat again. Okay, a 0 j hat. You can write negative plus, it doesn't matter here because it's simply 0. Okay, now for the k hat, crossing out the column with the k hat and the row with the k hat, so then we cross multiply this times this, which is 5 sine t times negative 5 sine t, so the negatives cancels out, so they're giving us with 25 sine t, right? And then we have to do negative this times this, and sorry, it's sine t times sine t, so it has to be sine squared t, and then negative multiply by this times this, so that negative cancels out, and then 5 times 5, which is 25, so plus 25, and then cosine t times cosine t, cosine squared of t. Okay, so we will have to write here 25 sine squared t plus 25 cosine squared t. So this is the cross product, and you can just simplify it a little bit, and let's just don't write this 0 I hat 0 j hat because it doesn't mean anything, so let's just don't write them. And yeah, there's a k hat missing over there, I'm sorry for that. And to simplify this, you just need a trig identity. So let me write it over here. So you just need this trig identity, sine squared of t plus cosine squared of t is equals to 1. So we're going to be using this trig identity to simplify this further. So factoring out the 25, so we factor out 25, so we are just left with sine squared of t plus cosine squared of t. So okay, and now we can replace this with this, which turns out to be 1. This whole thing turns out to be 1. So then this is simply 25. Okay, that the cross product of r prime of t times r prime prime of t gives us 25 only. Okay, now what's the next step? We have this, which is equals to 25. Now we have to find the magnitude of r prime of t. So we have r prime of t, so we can calculate the magnitude of this. And you guys remember taking the magnitude. So how do we take the magnitude? We square each component and then square root the whole thing. So let me write it over here. Okay, we're here. Okay, so this is r prime of t, so we're calculating for r prime of t magnitude. So we're squaring each component. Okay, 5 cosine t squared and then square rooting the whole thing. Okay, so this gives us 25 sine squared of t plus 25 cosine squared of t, and then not forgetting the square root, of course. Now we can use the same trig identity here, sine squared of t cosine squared of t equals to 1, but for that again we'll have to factor out the 25. So factoring out the 25 leaves us with this sine squared of t plus cosine squared of t and square root. So now replacing all this with this trig identity again. So this replaces with 1 then. So we're just left with 25 times 1 square rooted, which is simply square root of 25. And what's the square root of 25? You know it, okay? It's 5. So now we can just find our a tan. So we have this that we calculated, and what did we get? We got 25 for this, and we have this, and we got 5 for this. So it has to be 25 divided by 5. So a normal, it's simply 25 divided by 5, which is simply 5. So this is the answer for a tan. I hope you like this video, and I hope you found it helpful. Please subscribe if